Okay, let's see how to do the interaction effect analysis by regression model. This is our example in which we think that there is interaction effect between gender and smoking. So there would be a coefficient for the multiplication term, a coefficient for smoking, a coefficient for gender, and the coefficient for the confounder, which is the socioeconomic status here. So in this regression model, as you can see, we can put the multiplication term of the variables in the regression model. Before interpretation of the interaction term, we should see the coefficient of for the multiplication term. If it is significant, it means actually there is interaction effect between the two variable. Otherwise, we can remove the multiplication term, because when there is no significant if coefficient here, it means there is no interaction effect between gender and smoking. So we can remove the interaction term and we can say that there is no interaction effect between the two variables. But if it is significant, we have to do something else. We have to step forward. Actually, the interpretation would be a little bit complicated. So let's see what will happen in the case if the coefficient is significant. We'll see this so here. So actually, this is another example. Yeah, this is another example that I've done by Status Software. Actually, this is an example of software's website, the Status website. So I brought it here. So in this example, we want to see uh, the association between age, gender, and region with the BMI. So BMI is our dependent variable, which is a continuous variable, and we've got age as a continuous variable, gender and region, which are the categorical ones. So because the BMI is continuous, and in this case we have to use the linear regression. So this is basically a linear regression model in which we want to see the interaction effect between gender and region. And to do so, we put the double hashtags here. As you can see, we put the double hashtags because we want to see the impact of main terms. Actually, when we use the when we want to see the interaction effect, we have to put the main term of the variables themselves in the model. So let's go back to our example here. As you can see here, we not only put the interaction effect in the model, but also the main terms as well. So here, gender is the main term, smoking is the main term, and this is the multiplication term, which is the which we are looking for actually. So here, if you use double hashtag in the status software, we can see the main terms of the region and gender as well. So let's see the output here. This is the table of the output. In the first column, we can see the independent variables. The first one is age. The second one is gender. Sorry, this should be gender, which is a categorical variable, and we put the code 0 for female, for example, and the code 1 for males. And we can see the coefficient, which is uh, actually the mean difference between the males and females. And as you can see here, the mean value of BMI is lower in males relative to females as 0.29. So because the sign is minus, it means the BMI, the mean value of BMI is lower in males relative to females. So, and we can see the same. Actually, we can interpret the coefficient of region in the same way. And as you can see here, actually when we use the categorical variables in regression model, we have to choose a category as a reference value to be compared to the other categories. So here we've got four regions called NE, MW, S, and W. And as you can see, the last three categories have been compared to the first one. The first one is actually the reference category. So, what about the interaction term? As we can see here, we've got three coefficients. So let's see the first one. The first one, which is 0.28, and is a positive coefficient. So it means that the mean difference in this category is higher to the reference category. But what is that actually? It is not as easy as the region and the gender here. It is a little bit complicated, more complicated than the previous ones. So how to interpret that? Uh, Actually, we in this case we say that the mean value of BMI in the people who are from MW relative to the people who are from NE in male is higher than female as 0.28. I think I say something very complicated. So let's say the interpretation again. So the interpretation of 0.28 is oh, sorry for that. Yeah. So the interpretation is uh, we can say that the mean value of BMI in those people who are in those mean, actually, because you can see the category 1, which are the male people. So this coefficient means the mean value of BMI in the male people who are from MW is higher than those who are from NE, because the coefficient is positive. So actually in this coefficient compares male the male who are from the the region MW relative to those who are from the NE. So in actually, as I said, it's a little complicated and we have to carefully interpret the result. So let's see the second one. So we can interpret the second one just in the same way. Here, this is the comparison of mean value of BMI in the people who are from the region called S relative to the people who are from NE. But remember, in this case, we still use the same category as the reference value. We can, as you can see here, is the category 1, which are the male, and you can't see any coefficient for the NE, which is their reference value. So this is the interpretation of the coefficient. It's a little complicated, but actually in this case, because the variables are categorical, so this is maybe easier when we use the continuous variables. So when we use the status software, we use the continuous variables and interpret the results again to better understand the coefficients of the interaction effect. So this is basically the interpretation of the coefficient, the interaction effect in linear regression model, and of course we can estimate the interaction effect when we use the logistic regression or other models such as survival analysis. So this is it.